It is 4:30, so we will go ahead and get started. Thank you all for being here. To be most respectful of each other's time and our participation today, we do ask that you please mute your mics so that we can properly hear all of the speakers here today. The session is also being recorded. Thank you.
So for our session today, as you know, you've come to learn a little bit more about 3 different majors from CEAS. And today, this breakout session will define mechanical engineering technology, mechanical engineering, and aerospace engineering. So our first off is mechanical engineering technology. So mechanical engineering technology comprises the hardware and computer-oriented aspects of mechanical design, manufacturing, and energy systems in an applied fashion. And applied is the key term to remember here. METs use applied, established systems to design and to solve problems, to assemble, to manufacture, and to manage the act of manufacturing. So some of the 3 attributes that you might want to think about are, how does that mean co-op will go? What other opportunities at UC might you have? And then alternative pathways that METs might seek after MET or in addition to. So for co-op, METs can plan to experience maybe design and testing and manufacturing. There's mechanical design analysis. There's field installations of large equipment. There's machinery and software testing, power plant operations and other large infrastructure projects, and production planning. Other opportunities at UC might involve the Hyperloop project, Bearcat Motorsports, the Basic Utility Vehicle project, robotics, the Baja car, and welding technology. Alternative pathways might include mechanical engineering, physics, industrial management, building and industrial technology, industrial management, and a master's in engineering. So what we'd like to do now is have our first student panelist talk about some of the things that he's experienced and a bit about an exciting co-op experience. So we're going to have Keaton Glazer from the class of 21. He's a senior about to graduate. Go ahead and share with us.
All right. Okay. Hello, everyone. I'm Keaton Glazer. I'm a senior here studying mechanical engineering technology. Personally, what drew me to MET, I actually started in ME, coming from a family of mechanical engineers. MET was not actually very well marketed to me, so I was not very aware of it coming in, and so I just went ahead and jumped into ME. But I kind of always wanted to be more on the hands-on side of things, and then calculus was a little bit difficult, so I ended up switching over to MET because they only have to finish through calculus 1, plus being the whole hands-on aspect. The big difference in my perspective between MET and ME, MET is a lot less theoretical and it's more practical and hands-on knowledge that you'll get to use in your co-ops and your future career experience. We get to take some more hands-on classes like welding and machining, as well as a lot of lab classes. We tend to have some smaller class sizes than the MEs, since there are less of us, and so we have about 60 people in my class size, divided by the 2 co-op sessions. There's only about 30 of us, so you get real close with all the people in your class and they become some of your best buddies. And then there's only a few companies that really would rather have MEs instead of METs, so they're fairly interchangeable as career options and career paths. So far, I've got all 5 of my co-op experiences done, being a senior. So my biggest 2 companies were with GE Aviation and Honda. And so overall, these co-ops experiences are just invaluable. You learn a ton during these co-ops. You learn what you're interested in doing. Personally, for me, that is quality. I've enjoyed all those quality roles and finding what issues we're having with parts and how to correct those issues such that we can produce a high quality part that has no issues with it at all. And then, of course, those co-ops can help you pay for college as well. And so my future career plans are that I'll hopefully be able to continue on and get a full-time position with some of my co-ops. So, yeah, thanks very much, guys.
Thanks, Keaton. Okay, so from there, we're going to go on to mechanical engineering. Now, what Keaton said was key, that METs use applied, established systems to get the job done. The difference is mechanical engineers use principles. They use fundamental theories to develop new products and systems, and they use these same theories to model and analyze. Those are the big differences. So as opposed to being applied, there's a lot more analysis that goes on. And that's in the design, manufacture, and operation of machines and mechanical systems. So our three attributes that this might apply to for a prospective ME student. So we've got the co-op path. You're going to see a lot of overlap here between ME and MET. We have design, testing, and research development. We have manufacturing, machinery design, automotive design, technical sales. For other opportunities at UC, we've got research, Hyperloop project, robotics, and Bearcat Motorsports. And in terms of alternative pathways, just as an MET might seek ME, an ME might seek MET, Mechanical Engineering Technology, Physics, Industrial Management, a Master's in Engineering, and Building and Industrial Technology. So now we'd like to hear from our student panelist for ME. Today we have Vladimir Moskovich here, and he's from the class of 23, and he'd like to tell you about his experiences.
Hello everyone, my name is Vladimir, and I am officially third year mechanical engineer. I'm also minoring in mathematics, and I'm just now in my second co-op with the company called Leone Wiring Systems. It's a German company, and it operates worldwide, and if you drive a German car, most likely all the wiring inside is produced by that company. I'm in the I'm in a construction vehicle division, so I work for a customer called Caterpillar, and I'm in many different roles over there, as quality, some sales, some purchasing, and just whatever needs to get done, they pretty much just put me there. My experience with mechanical engineering was that I didn't quite know what I wanted to do. So first semester, I didn't have a major, and then I looked into many different things. And what I discovered is that mechanical engineering really gives you the opportunity to pursue kind of everything and to see a little bit of everything, so you can decide later on, like, what would you like to do. And this ranges all the way from like the hardcore engineering all the way to sales. So I see in my company, for example, some people that are that graduated as mechanical engineers back in the day are now in some completely different roles, usually like managing or sales roles. So that was the main reason for me to pick mechanical engineering, and I see that I can really get a lot of things done, and I know a lot of things about the hardware and software. And if you pair maybe minor in computer science with that, there is really nothing you can do. Thank you.
Thank you, Vladimir. We really appreciate your perspective on that. And now we're going to move on to aerospace.
Hello, everybody. I'm Eric Hinkle. Along with Emily, I advise for Aerospace Engineering. So the key with aerospace engineering, which is kind of self-evident, is that its focus is on the development of vehicles in flight. So while it's using certain mechanical engineering principles, its focus is on how those mechanics work in aircraft, spacecraft, missiles, rockets, satellites, anything that's flying. Aerospace is working on the engineering behind that. So, as the same format that Sean had been talking about before in terms of career and co-op, opportunities that you see, and then alternative pathways that you might consider. When we're looking at kind of your career co-op areas, similar to mechanical, you're going to be looking at things related to the design, testing, research, and development, only specifically towards things related to aircraft, spacecraft, missile design, testing. So you'll look at aircraft design and their mechanics, as well as spacecraft. Obviously, flying vehicles, missiles would also be a part of that, because obviously they're passing through the air and flying, and obviously any testing related to those mechanics of aerospace. As you can imagine, defense technology is a huge component of that. The military, as well as NASA, among other organizations in the government, deal with a lot of spacecraft and aircraft. So there are many opportunities there. Areas specific for space exploration, obviously domestic airlines and diagnostics related to that, and just the general engineering of anything related to aircraft. So opportunities that you see, research opportunities specific to the area of aerospace engineering, Fly UC, rocketry organization, CubeCats, Drone Club, and also Hyperloop. So all of those organizations deal with some aspects of aerospace engineering. Some other aspects and fields that relate to aerospace engineering, geology. Obviously, studying the atmosphere is incredibly important in terms of its impact on aerospace engineering. So that's obviously very much related to the theories behind aircraft. Aviation technology, it's pretty self-evident. Physics, of course, is foundational to any engineering field. So it's obviously related. Astrophysics is obviously dealing with physics specifically related to space. And of course, master's engineering in aerospace, as well as other related fields. Next, we're going to have Sharon McCumber. She's an aerospace engineering student, class of 2022, and she'll be sharing with you some of her experiences.
Hi, I'm Sharon McCumber. So this is my third year of aerospace engineering. Sorry for this background noise. And I am in the Ascend program, so I will be graduating in 4 years with my bachelor's degree, but it's my third year, so it's kind of weird. And then I'll be going into my master's, my 4th and 5th year. And basically how I chose aerospace between all the other engineering majors was I did Project Lead the Way, which is like, it's called PLTW. It's like a high school kind of program to introduce students to engineering. And I took like a aerospace course, and it was very basic, basically talked about like, fundamentals of flight, thrust, weight, all of those things. So that was kind of what introduced me to aerospace, and I just started getting ahead in my classes and taking, as many AP credits in physics and calculus as I could, because I knew that was going to be rigorous in college. And so I kind of just stuck with it throughout. And I ended up co-oping with Aurora Flight Sciences out in Manassas, Virginia, right outside of DC. They are a Boeing subsidiary, and they're basically acquired by Boeing because they do a lot of experimental aircraft, and they work a lot on UAVs or urban air vehicles, which is a very new concept kind of in the aerospace industry. It's basically like flying cars and stuff. That's kind of what they delve into. I worked on Centaur, which is an optionally piloted aircraft, and it can be basically flown unmanned, largely for surveillance. So yeah, basically, if you guys have any questions, I guess, about how aerospace differs from mechanical, you guys can ask. It's pretty similar. We have a lot of the same base classes like thermodynamics, fluid dynamics, all of those things, but 3rd or 4th year, we start to delve more into like supersonics and basically how really high velocities are going to be affecting your engines. And, going to space, that's a whole nother concept, but it's a lot of the same, base concepts and principles as MET or ME. So, a lot of the places that aerospace, engineers work at, mechanical engineers work at, and vice versa. So if you guys have any questions, feel free to ask.
Thank you, Sharon. So here's kind of an overview of the different engineering fields that we've discussed: mechanical versus mechanical engineering technology versus aerospace engineering. So first will be kind of the program emphasis. So really, when we're talking about mechanical engineering, we're talking about more the fundamental theories behind mechanics and how they can apply to different situations, where mechanical engineering technology is more about taking those already established principles and procedures and applying them to different systems. So the ME being more theoretical, the MET being more rooted in practical application. Again, there's overlap there, obviously, but it's just a question of emphasis. And obviously with aerospace, the focus is more on the design development of flight, things specifically related to all that flies. So curriculum, naturally the mechanical is going to focus more on the theoretical and models and analyzing those models and systems, where the MET is going to focus more on theoretical application, more labs, more hands-on approaches. And Aero kind of takes somewhat of both. It has both the theoretical and the practical, but specifically related to those things that relate to flight. In terms of the workplace, as you can imagine, again, there's going to be applied mechanical research, computer-aided design, manufacturing, energy systems, biomedical safety, HVAC. Mechanical touches just almost any kind of engineering aspect you can imagine. So it's a very, as Vladimir's alluded to, a very broad field that touches on a lot of different areas. MET is obviously going to be focusing more on those established practices, those established procedures in engineering, and implementing them in relationships to construction, manufacturing, sales, distribution, etc. And Aero is again going to focus on those kind of design and product manufacturing, consulting, and all that deals with flight. So that covers everything from spacecraft and NASA to the Air Force and the military to the Navy, obviously also has flight vehicles, and obviously to domestic flight as well. So this is just some contact information for all the academic advisors in these different areas, as well as our undergraduate presenters today. Please feel free to ask questions in the chat, and we can kind of read those out and try to get some information to you. They can be directed to advisors or even preferably to our student presenters here, if you would like some insight from them.
Well, while everyone's thinking about a question to ask, there was a question asked in the last session that was, I thought, awesome, and you guys gave great answers. Talk about some cool projects y'all are working on right now.
So during my second co-op, working for GE Aviation, I actually got to go to Boston, Massachusetts, and they basically had me as a manager for a production line for a combustion section of an engine that the engine was for our US military Black Hawks and everything. So it was very cool to be able to see and be a manager for a very key, crucial section to a very unique engine. So.
You can go, Vladimir, because you didn't go last time.
Oh, okay. So I'm currently on co-op, and this semester I'll be managing the prototype build for one Caterpillar machine called a skid steer loader, and this is a machine that will be in production probably next 4 or 5 years. So it's very nice to get like this, like peek into this industry and see like what's gonna be new and what's gonna be exciting for the end customers to use down the road. So I manage pretty much everything from like you know, stuff in the plant, supply chain, purchasing, sales, all these things that like go into a prototype build. Everything is new, so no one really knows how it's gonna look like and all that. So it's pretty exciting. Also, with that comes like constant excitement. Like yesterday, I didn't even know that I would have to go anywhere this semester, but I just realized that I have to go to North Carolina for 2 weeks because some harnesses that have been sent over there are not good and they need to be reworked. So that's kind of a cool project that I'm working on this semester. And Sharon, please go next. Thank you.
Yeah, so I worked on Centaur for both of my co-ops, which is the program that I mentioned earlier that is an optionally piloted aircraft. It basically flies in 4 modes: manned, unmanned, hybrid, or unmanned +1. Those are all different types of like control architecture configurations. And my first co-op, I did kind of like a program management role, and I kind of like oversaw the overall project, which gave me a like broad scope of basically what the company did and its integration into Boeing and kind of like the growing pains with that. And I made like a risk register and did a few other things, met with the IPT lead. So I kind of got to learn a little bit about like the electrical side, the structural side, the software side. And then this past summer, I was out there, but I was in my apartment most of the time unless I had to come in for a few things because of COVID. And I worked in the CIT team, which is Systems Engineering, Integration, and Test. So I wrote a lot of requirements on the system side. And then I also worked with the HillSim, which is hardware in the loop simulation for our aircraft, which basically you can run missions and things like that. You do that with a lot of experimental aircraft, and worked with their HMI or human machine interfaces on their ground control station. So I got to interface a lot with those things, and that's the project that I've mostly worked on, but it's been really cool and lots of learning both times that I've been there. So.
Thank you, guys. So we do have a question in here. Does ME or MET deal more with research and development of vehicles and such?
So at least in my experience, working at Honda, there's no big difference. Both MEs and METs can work in R&D. There might be a slightly higher chance that an ME would be working in R&D, but MET might also have more of a background in materials and such that an ME would not. That would also give them an upper hand in the R&D field. So it's kind of either one would work probably.
Yeah, if I may just add, so don't let your major decide on what you're going to do. Once you're in the field, you are the one that decides what you're going to do, where you're going to go, how good you are is going to manage that. So all 3 of these majors are very good, and you're not going to go wrong with any of this. You're not going to have shortage of money in any of these. You can do whatever you want if you're good at it. So and now in industry, like what does the purchase order have to do with mechanical engineering? Really nothing, but you know, you have to do all these different things. So the major doesn't really matter. Trust me.
Thank you so much for sharing that, Vladimir. That's really, really excellent advice. I hope everybody heard that and takes that to heart. That about does it for us. So if everyone is able to go back to that main room that Corinne Cook will be presenting in for a quick wrap up, we would appreciate it. Thank you all very much for being here today.